10.5 to 10.6 area of parallelograms, trapezoids, rhombuses. I can find area and missing dimensions of parallelograms, trapezoids, rhombuses.
Okay, cool. So again, there is a lot going on here in this particular lesson. We are finding areas, we are finding missing dimensions, and we even talked about Pythagorean theorem. Parallelogram. You can find the area of a parallelogram by using the same formula as what?
Rectangle.
You can find the area of a trapezoid because you didn't wake up for a full week. Luke, our eyes are up here. I thought I was pretty clear on that. You can find the area of a rhombus and a kite because they are the exact same. Actually, that's not why you can, but they are the exact same. Everyone knows what area is. Yes, no?
Yes.
Parallelograms. What are true about the opposite sides of parallelograms, everybody? They're congruent and parallel. And everybody knows what these congruence markers stand for, yes or no?
Yes.
It means same length and same length. Rectangle, we're all good with that. Trapezoid. We have a trapezoid down here. We know that a trapezoid have parallel sides. Is this a trapezoid?
Yes.
Where are the bases? On the top and the bottom or the left and the right?
Left and the right.
They're on the left and the right because, everyone read this on the count of 3. 1, 2, 3.
The bases are the parallel sides.
And that would be true of a trapezoid. The bases of a trapezoid are the parallel sides. They're not necessarily the top and the bottom. It's just the parallel sides. Rhombuses and kites, we see definitions and pictures there. You definitely need to understand what a rhombus and a kite is. Parallelogram, then, we just talked about this. To calculate the area of a parallelogram, it's the same as a rectangle. It is? Area of a parallelogram is? Base times height. Is this a base or a height?
No.
Is this a base or a height?
Yes.
We're going to call it the height, right?
Yes.
And then this is our base. Remember, be careful. A side length that is at a diagonal like that is not going to be the base or the height. It's going to be a side length. Okay, cool. Missing dimensions, algebra. Wow, we did some algebra here. So on number 9, for example, just talk about number 9. I gave you the height and I gave you the base, yes or no?
Yes.
And I gave you the area, yes or no?
Yes.
Is it a good idea to write down the formula for what you're trying to discover?
Yes.
So what is the area? What is the area of that rectangle?
36.
36. So we filled in A with the number 36. Do we know the base?
No.
So we left the base as B. Could we called it X as well?
Yes.
Do we know the height?
Yes.
What's the height?
4.
4. So we just need to calculate B, and you guys all probably know what it is, like guess and check. You all know that what times 4 is 36? 9. But if we want to solve it algebraically, or if we don't know that, you simply divide both sides by 4. Because what do we want to do with the letter B? We want to get it how? We want to get it alone. And how do you undo multiplication to get the letter B alone? Divide. And if you divide on one side, you have to. Is guess and check an okay method too if you forget?
Yes.
Totally. But that is how you would solve for it. Moving down, I'm going to skip over 10 and 11, are just more for your reference and same exact type of problems. Area of a trapezoid, we already talked about, and you did it in Wake Up. Be careful. Can formulas be given in different ways?
Yes.
That's the one I gave you in Wake Up. This might be the one that they give you on the MCA test. Are they the exact same thing?
Yes.
We're adding the bases together, we're adding the bases together. We're multiplying by the height, we're multiplying by the height. We're dividing by 2, we're dividing by 2. Either of them work. Okay? And then number 5, area of rhombuses and kites. You have 2 different formulas. Again, this formula is the exact same as that formula. Pick whichever one you like the best. What does D stand for in the formulas? What does D stand for? And diagonals are? Okay, so we drew you a picture down here. The black dots, do they represent consecutive or non-consecutive vertices?
Consecutive.
The black dots represent consecutive. So these just make an edge or a side. The green dots represent what kind of vertices?
Non-consecutive.
Okay, so then a non-consecutive vertices, can we draw a diagonal? Yes, like I just did. Wonderful. And then to find the area of a shape like number 15, is this our diagonal?
Yes.
What's the length of that diagonal?
16.
Is this a diagonal?
Yes.
What's the length of that diagonal? So you simply take those 2 measurements and plug them into your formula. So we use both formulas here. We've got 1/2 times 16 times 9, which gives you 72, or we use the second one, 16 times 9 divided by 2. Okay? And And then here is your challenge. If you really were comfortable when we did Pythagorean theorem, I would go through this one again. Chances are you'll see this on the test, but it'll be extra credit. If Pythagorean theorem really messed you up, don't worry about this one. Just worry about finding the area of a kite. Does that sound fair?